In this lesson, I'm going to be talking about the natural logarithm function and the integration having to do with that function. And I've already kind of talked about this in a previous video about what the antiderivative of a function is. So our first example here, if I bring the 3 out in front, we have the integral of 1 over x dx. What function's derivative is 1 over x? That is the ln of x plus c. Now, something I want you guys to keep in mind is you need these absolute value signs. Because remember, I call this the inside part of the logarithm. That's not a technical term, but the inside piece of the logarithm has to be positive. But this function can be positive or negative, okay? So now this function, and this combines a couple things that we've been talking about already. This is a u substitution. Typically, in a u substitution, make your denominator what your u is. So du is negative 5 dx. So I multiply by a negative 5 there, a negative 1/5 there. So I have negative 1/5 the integral of 1 over u du. So that's negative 1/5 the ln of 2 minus 5x plus c. And again, remember, you can always be taking the derivatives of these to check and make sure that your answer is correct if you want. Find the area of the region bounded by this graph, the x-axis, and the lines x equals 2 and 5. Remember, that's what integration is finding the area to the x-axis. So I'm going from 2 to 5 of 6x squared over x to the third minus 5 dx. And again, make your u equal to x to the denominator. So du is equal to 3x squared dx. Now look at what I'm going to do here. Sometimes I think about math a little bit different than other people. And I don't know if that's good or bad. But 6, I need to get this to be 3x squared. So I could make that 2 times 3x squared if I want. So now I have my du. I can bring that 2 out in front. Ooh. Ooh. I didn't even realize I did this in this problem. I'm going to erase these integral values. Because if you notice now, I'm going to be writing this all in terms of u. So I have my du over u. And these integral values are in terms of x. So I don't want to write those because that'd be an incorrect statement. So I go through and I find my natural log of the absolute value of my u. And now I have to evaluate that from 2 to 5. So I go over here and I plug in a 2, or I plug in a 5 for my x, and that is 125. Minus the ln, if I plug in 2, I get 3. And remember, this should be 120, not 125. 5 to the third is 125. So this becomes the ln of 120 over 3. Okay, so that was kind of combining with the u substitution, and then I chose not to change them. If you want to change them, you can change them. Evaluating this integral. Yeah, we have to manipulate this. Cotangent. Cotangent can be written as cosine of 3x over the sine of 3x dx. So now what you want to do is you want to make your denominator your u and make the whole denominator your u. So du is derivative of sine is the cosine 3x times 3 dx. So then from here, what I'm going to do is, sorry, I got completely distracted. I need a 3 inside, a 1/3 outside. I'm thinking about something else and trying to record a video, and that just didn't work for me. 1 over u du 1/3 the ln of my u plus c. My u was the sine of 3x. Okay, our next example. I skipped example 5. It's something that we'll probably be doing in class, maybe give you guys a few problems to work on depending on which day this falls. But now looking at this one, evaluating that integral. Okay, this is what we call an improper fraction. The exponent on the top is bigger than the exponent on the bottom. If you see that, you can't really use a u substitution. What you have to do is you have to do long division, or I like to do synthetic division to simplify this. So I have a -5. I do synthetic division. I think maybe because I teach it in Algebra 2 Trig. I just think it makes things easier. So I bring down by 1, I multiply, we add, we multiply, and we add. I don't know why I can't add that. Okay, so from there, what this really means is this really means that this can be simplified into x minus 9 plus 51 over x plus 5 dx. Now I can integrate each one of these. I can integrate the x and get 1/2 x squared minus 9x plus the integral of this, if you want to make your u substitution, x plus 5 du is dx. So it's really 51 ln of x plus 5 plus c. Okay, the next example. Ooh, I got some fun ones in here. I'm looking at these. Man, these are fun. Go with what I've been telling you. Okay, make your u your denominator. So make your u your denominator. So your du is equal to -3 dx. So I need a -3 in there, and I need a -1/3 out in front. Man, I got some good problems in here. So I have my u squared, I have my x, and my du. We've had a problem. We've had a problem with this x. That x can't be there. So what you have to do is you have to look at this equation here and solve for x. So I'm going to subtract the 2 over, and I'm going to divide by a -3. Okay, and I'm going to substitute this in here for my x. So I have -1/3 the integral of u minus 2 over a -3 times u squared du. I'm going to bring this -1/3 out in front. So that becomes a 1 out in front. And I have u minus 2 over a u squared du. Now remember, there's no rule for division. So what we have to do is we have to change this to 1 over u. minus 2 over u squared du. Now keep in mind, this antiderivative is the ln of u. This antiderivative is not. Okay, remember, that's the integral, I'm going to bring the 2 out in front, of u to the negative 1 du. Add 1 to your exponent. I'm sorry, that's the negative 2. Add 1 to your exponent, 1 over your new exponent, plus c. Now I need to substitute in. Oh, I messed something up here. What did I mess up, guys? Nobody yelled at me because I'm recording a video. This should be a 1/9 out front. So I should have this whole thing being multiplied by 1/9. I'm looking at my answer now. I know I have the right answer. I don't know why. I was thinking the 3 and the 3. I was being too optimistic that they would cancel. This example I'm going to do with you guys. Solving the differential equation. Now, we really haven't done this yet. I think it's kind of fun that our book kind of throws this in here, even before we've talked about differential equations. So differential equation is an equation that involves a derivative. And you have your derivative there. So when I take the integral, okay, so when I take the integral, I'm going to do something different. I'm going to multiply both sides by dx. So I get dy equals 3x squared over x to the cubed minus 2 dx. Now I can take the integral both sides. I didn't like what I was going to do there because I didn't have that dx over there. On this left side, I get y. On the right side, again, we have the integral of 1 over u du. That kind of worked out nicely. So that turns into y equals the ln of x cubed minus 2 plus c. And you just solved your first differential equation. We actually do a whole chapter on that. Okay, that was a fun video. Some fun things happen in there. Please make sure you are ready for class.